Hello everyone. In this video we are going to see a very beautiful and general topic which is photovoltaic conversion, and we'll also be having an introduction to the very famous photovoltaic cell or solar cell, which is a current trend. Okay. So photovoltaic conversion, as you know, is the direct conversion of electromagnetic energy of the sun into electrical energy using a photovoltaic cell. So the photovoltaic conversion is a direct conversion where the sun's rays energy is being converted into electrical energy. And such PV cells, photovoltaic cells, are also known by the common term as solar cells. So their highlight is that these cells can convert sunlight directly into DC power without emitting waste products. Okay, so the direct conversion without any waste, and please note that it is converted into DC power. The photovoltaic effect is exhibited by many materials, but the most commonly used, or which we consider as the most useful one, is the semiconductor materials. So they undergo the most useful photovoltaic effect under the solar radiation. So we'll just see what is a photovoltaic effect. The photovoltaic conversion basically involves the release of free electrons by the action of photons from the solar energy on the semiconductor material. So these free electrons are made to flow as electrical energy in a circuit to do work, and the flow of current is achieved by the creation of an electron-hole pair and flow through an external electric circuit. We'll see more in the coming slides. So this is a representation of a photovoltaic cell. I said we use semiconductor. So as you can see, there is a p-type silicon and you have an n-type silicon. So this forms your p-n junction. And as the solar radiation falls on this, there is generation of electron hole, and this electron hole pair generation causes this p-type silicon to be positively attracted or to possess positive charge, and the n-type silicon possess negative charge. And once you connect an external wire along with the load, you have the flow of electricity. This is more described in the coming slides. So a silicon PV cell is fabricated by forming a junction between two different materials in a single crystal of silicon. Silicon as such, if you take, it is a poor conductor of electricity. So what we do is, we do the process of doping. Doping means to add impurities to it. So by adding a trace of another element like arsenic or phosphorus, which is going to contribute one more electron, it is made to a conductor. And that type, is known as the n-type silicon, where the conduction is obtained by the negative free electrons. And you have another type, which is the p-type silicon, and for that the dopant means the impurity that you add. The dopant used is boron or gallium, which is going to contain one less electron than the silicon. So that is how you form this n-type silicon and p-type silicon using doping. So the absence of electrons in the p material creates positive charges on holes, so that the silicon also becomes conductive. Now the boundary between the two regions, n-type and p-type, in a single crystal establishes the p-n junction. So when a semiconductor wafer, usually a thin strip, is exposed to sunlight, some of the solar photons are absorbed in the vicinity of the p-n junction, and in the process the electrons in the valence band gets excited. So what happens once these excited electrons, they move from the valence band to higher energy levels, and as a consequence they leave holes in the valence band. So this creates electron hole pairs in the material, and the electron in the conduction band has a negative charge and the hole in the valence band has a positive charge. So in effect, what happens is the electrons and holes are going to be your negative and positive charge carriers respectively. Okay, so the electric field of the p-n junction causes these negative and positive charges to move in opposite directions. So the n-type semiconductor material on one side of the junction becomes negatively charged, and the p-type material on the other side becomes positively charged. So when an external load is connected, naturally the existing potential difference created between the p and n sides will cause an electric current to flow through the circuit and the cell. The newly formed electrons and holes flow across the junction in opposite direction to form the electric current. So this diagram gives a more detailed explanation, where you can see the p junction the p-type silicon, the n-type silicon, and the junction, the valence band, the energy gap is also shown when the photons are hit and the electron hole pair generation happens, how the valence band is getting holes and how the conduction band is getting electrons. And once you connect an external circuit, you have the flow of current. Let's see the advantages of PV cells. Less maintenance, long life, unlimited energy source, and they can be made from raw materials that are available in huge quantities. But to quote some disadvantages, they produce very little power at very high cost. The output is not so constant, it varies with the time of the day and weather, and it is useful for special applications where the power required is very small. To quote the best example would be a solar calculator. Okay, thank you.